So let's consider a couple of examples where we need to calculate technically the curvature of a vector function. So we're going to start with the equation of a circle. So as the equation of the circle is a vector function is given as the r cosine of t, r sine of t, in the TD, right? So if we drew this, this is going to be this kind of graph. So do you remember when we define a curvature, we say, okay, so for every given point, we're going to make a circle which are going to match with the borders of the, so the borders of the circle are going to match with the curve, right? So since our curve is a circle, so whenever we choose a point, it's going to be the same circle which we need to draw in order to match these borders, right? And the curvature, by its definition, should be reciprocal of the radius of the circle. So let's show that this is true. So what we're going to do is we're going to use this formula in order to calculate the curvature, right? So the r of t is given as the radius multiplied as a cosine of t, the radius multiplied as a sine of t. So first of all, what we need to do is we need to calculate the derivative of the r. It's going to be r minus r sine of t and r cosine of t, right? So here on the denominator, we need to calculate the norm of the r prime. It's going to be minus r squared, or minus r squared, r sine of t in a square, plus r cosine of t in a square from the square root, and this is going to be equal to r squared sine square plus r squared cosine square. If I take out the r squared from the brackets, it's sine square of t plus cosine square of t is left, and we need to take the square root, so this is equal to the 1. So what is left is r squared from the square root. This is going to be simply r, right? So now let's calculate the tangent vector, right? So the tangent vector, or the unit tangent vector, is when we find the derivative of the function r and divide this to its norm, right? So our derivative of the function is minus r sine of t, r cosine of t, right? And we need to divide this to the norm of the r prime, which is simply r. So when we divide a vector to some constant, right? So it means that every component of this vector should be divided to this constant. So what we have is simply minus sine of t and cosine of t. So what we need to do is we need to calculate the derivative of this function, right? Derivative of the t, it's going to be derivative from the minus c, which is minus cosine of t, right? And derivative of the cosine is minus sine of t. So when we need to find the norm of this vector, we need to square the first component plus the square of the second component, which is going to be equal to the 1, right? So here it's going to be minus cosine square is simply cosine square of t, plus minus sine square, it's going to be sine square of t from the square root, divided to the norm of the r, which is simply the radius, right? So which is going to be 1 divided to the r, which matches with our definition in our feeling about the curvature, right? So we say that we're going to define a curvature as a reciprocal of a circle, which we need to draw so that the borders of the circle are going to match with the curve. So let's consider another example. So we need to find a curvature of a helix, which is defined with this function. So the helix looks like this, right? So we are going to have a third parameter of our vector r. So r is going to be cosine of t, sine of t, and the t. So as we increase the t, it's going to change its height, right? It's going upper. So let's find the curvature using this formula. So what we need to do is we again need to find the r prime. So this is going to be minus sine of t, cosine of t, and 1. So when we find its norm, the norm of the r prime, it's going to be square of the sine, square of the cosine, which is equal to the 1, right? Square root, square of the sine, plus square of the cosine, sine square of t, plus cosine square of t, plus 1 in the square, right? So it says this is equal to the 1, what we'll have is square root of t. So now we need to find the unit tangent vector. So unit tangent vector is defined as r prime divided to the norm of the r prime, right? So this is going to be 1 over square root of t multiplied to the r prime, which is minus sine of t cosine of t in 1, right? So we can multiply all of the things to, so 1 over square root of t to all the 3 components of this vector, or we can just leave it like this for a while. So now in order to calculate this component in the formula, we need to find the derivative of the t. It's going to be 1 over square root of t and derivative of each component of this vector. So derivative of the minus sine is going to be minus cosine. So derivative of the cosine is going to be minus sine. And derivative of the 1 with respect to the t is going to be 0, right? So what we need to do is we need to find the norm of the t. It's going to be square of the first component. So let me rewrite a constant first of all. It's going to be multiplied to the norm of this vector with the components minus cosine of t, minus sine of t, and 0, right? So the norm of this vector actually is equal to the 1, right? Because it's going to be 1 over square root of t multiplied to the square root of cosine square root of t plus sine square root of t plus 0 in a square, which is going to be 1 divided to the square root of t. So the curvature to the helix, it's going to be t prime norm. So this is the prime, right? Sorry. So t prime norm, which is 1 divided to the square root of t, divided to the r prime norm, which is square root. So here r prime square root of t. So this is going to be 1 divided to the t. Okay, so let's go to the next problem. Next example, we need to find the curvature of the twisted cubic with this function. Now, in order to do this, we're going to use this formula, so which we obtained recently in a previous video. So the kappa of t is going to be a cross product of the r prime with the r2 prime divided to the r prime in a cube, right? So again, r of t is given as a vector is a t squared, and t cubed. So first of all, we need to find the r prime. It's going to be derivative of the t with respect to the t, which is 1. Then derivative of the t squared is going to be 2t. And derivative of the t cubed, it is 3t squared. Now we need to find the second derivative of this function. It's going to be derivative of the first component, which is 0. Derivative of the second, which is t. Derivative of the third is 6t. So what we need to do, first of all, is we need to multiply the r prime to the rt primes, right? So which is equal when we find the determinant of the following matrix. So in the first row, we need to copy I, j, k vectors. On the second row, we need to copy the components of the first vector, which is r prime here, right? Which is going to be 1, t, and 3t squared. And on the third row, we need to copy the components of the second vector, which is 0, t, and 6t. So the determinant of this matrix is obtained by going through the entries of the first row. So we need to choose the I, cross the row in the column where it is located, and copy the entries which are left. So 2t, 3t squared, t, 6t, minus j. So we're going to erase the column in the row where the j is located and copy the entries which are left. This is going to be 1, 3t squared, 0, and 6t, plus the k. And then we're going to delete the row in a column where the k is located and copy the entries, which is going to be 1, t, 0, and t. So now let us going to find the determinants of the 3 matrices. It's going to be I multiplied to what? It is a 12t squared minus 6t squared minus j is 1 multiplied to the 6t minus 0 multiplied to the 3t squared, which is going to be simply 6t, plus the k multiplied to the 2, right? It is going to be a vector with a component 6t squared, 6t was the minus, sorry, and the 2, right? And the norm of this vector, so r prime cross product is r2 prime, it's going to be 6t in a square, which is going to be 36t4, plus 6t in a square minus 6t squared, it's going to be 36t squared, right? Plus 2 in a square, which is going to be plus 4. So actually here we can take out the 4 from the square root, right? So we can write down this 4, it's going to be 9t4 plus 9t squared plus 1. Okay, so at the same time in this formula, we need to find the norm of the r prime of t, right? So the norm of the r prime of t, it's going to be a square root of 1 and a square plus 4t plus 9t and a degree of 4, right? Okay, so now we need to put everything to the formula. So the curvature to this function, it's going to be r prime cross rt prime. That's going to be t square root of 9t in the power of 4 plus 9t in the power of t plus 1 divided to 1 plus 4t plus 9t in the power of 4 square root in the cube.